Okay, hey everyone. So, sorry for the delay. I actually had problems with one of my cameras, so I had to find the other one, connect it, and now it seems to work. And then I had to get my tea. Yeah, you know, tea is important. You cannot really hack without having a teacup full of tea, at least in my case. Anyway, so today's stream is going to be actually kind of random, as in I don't really have a topic in mind, so I'll probably talk about random stuff. I have some news, some updates, some changes to the stream, which I think you like, at least I hope you like. And then I probably skip to some technical stuff as well. I have an idea what I can talk about, as in one of the topics that I'm frequently asked about is about brute force and how to brute force a crack so I might show something I've actually learned on the last CTF, which is using a SMT solver. Yeah, so might get to that. Okay, so also if you have any questions, then just let me know on the channel. So in the description here it says that KrzaQ is today's moderator, but he has a random internet connection today, so actually just let me know on the channel or the chat or the YouTube chat, and I'll try to answer the questions which come in if I notice them. Sorry if I don't notice them actually. Sweet. So news. First of all, my CTF team, which is Dragon Sector, actually finished the last season on the second place. Now I realized one thing I didn't run is my Zoomit program from the sys internal tools, and thanks to which I can do this. This is actually the second year in the row where we finish on the second place. In 2014 it was actually first place, in 2013 it was the third place, which means 4 years in a row we managed somehow to stay in the top 3. So as the captain, I'm actually really proud of my team. And this season, as the previous season, is actually mostly thanks to Valis, and Redford. Valis is our acting captain, which means he's actually doing my job, as in I'm slacking off and not playing as many CTFs as I did in 2014, and he is handling the team with Redford, and they're doing like a really great job. So thank you guys for doing that. I played a couple of CTFs this year, I don't know, below 10 I think, or about 10. Still, I managed to play the last one, which was pretty important. Actually, that's a funny story here, because it was pretty clear that DCUA, let's maybe resume that. It was pretty clear that DCUA will be top 1. I mean, they had like 200 points or 300 points above all the other teams. Now, it wasn't clear for these 3 teams, since their place actually depended on the weight of the last CTF, which was CCC. The CTF. My face is actually here. Sorry, I need to move it. Yeah, let's maybe do this. Yeah, so this is CCC CTF. That was the last CTF of the year. The finals played actually like a day before, New Year's Eve. So everything in the end was about like what will be the weight of the CTF. If the weight in the voting would be around 70, then we would be on the 4th place. If it was about 75, then we would be 3rd place, and above we would be 2nd place, which basically means that all these 3 teams here is basically a tie. I mean, I'm considering a tie. It's visible here that the point difference is minimal, and the CTF season was super close actually, so yeah, the point difference is like negligible. I consider all of these 3 teams being like ex aequo on the 2nd place. So congratulations to DCUA, of course, and to LCBC and PPP as always. I mean, PPPR and LCBC are basically forever in the top 3 as well. So yeah, a great year, and I'm really happy. And let's see how the next season goes. And actually, let's get to the next season, which is this season. There was already first CTF in this season, which is Insomni'hack teaser. Now, the format usually was around 5 to 8 tasks, and whoever, like the first 3 teams who solve them, get hotels for the main event, which is happening in March in Switzerland, in Geneva. Now, this year it was a little different. There were actually 16 tasks, so that's like twice the amount, which kind of mixed up some of our plans, surprisingly. But we still managed to play. Most of us managed to play full-time. Some of our team was not able to play full-time, mainly due to traveling to Japan to second CTF finals, which Dragon Sector is also attending. In the end, we won. It wasn't like... every year we basically solved all the tasks. Like I'm saying every year because this is the fourth time. The fourth time we won the Insomni'hack CTF teaser, which I'm also pretty happy about. And usually we solved all the tasks. This year that was not the case. We were not able to solve the last task. There was actually this task called Encryptor. It's here. It was a 500 reverse engineering plus crypto challenge. And due to this, we had to sit on our feet basically up until the end of a CTF and be worried about some other team, for example, Tasteless, the second place team, or N3Ps or P4 solving all the challenges that we were, including the one we were not able to solve. Actually, Encryptor was solved only by PPP. Now, I'm saying that we didn't solve it, which isn't... It's kind of true. We didn't solve it, but the guys who were on the plane to Japan, it's a 12-hour flight, they actually managed to solve it. And I ran after like they landed, it was already like after the CTF, a couple of hours. They landed, they sent me the exploit, and we decrypted the JPEG, which was there with the flag. It took a while though, so yeah. And unfortunate timing, but we still managed to. And so again, I'm really proud of my team and the guests who played with us, because in Dragon Sector we usually play with guests. I think that's true for most teams, especially that our process or how people join Dragon Sector is actually they need to play as guests first. Sweet. Yeah, there's actually like a great amount of great teams in the, like, when I'm scrolling here, like top 20, top 30, like these are great teams and really awesome people. I actually hope to see most of them in Geneva in March on the Insomni'hack, the main CTF. It's an offline CTF where there are usually like 400 people playing in 8-person teams usually, and I really love the CTF, and I hope this year it will be a blast, and I'm pretty sure it will be, actually. So yeah, now they also published like some, this doesn't work, oh, I thought it will work well, whatever. They also published some information about the teaser, as in which tasks were solved by which team first, and in our case, we actually solved 3 tasks as the first team. That was the Great Escape, which was a Pawn 200, and it was actually solved only by 10 teams, and I don't really understand it. I did this task. I solved this task as the first team, right? So I solved it as the first person, and it wasn't that hard. There was one trick there, but apart from that, it wasn't hard. I can actually show you the task in a second. When we solved Internet of Fail, which was an Extensa architecture, Q3K or KrzaQ actually solved it in our team, and great work there. Quite a lot of reverse engineering. And in the end, WinWorld, that was a challenge which... I was joking, but it was made for Mateusz Jurczyk, one of our vice captains. He solved it as the only sole person, like you can see here, 1 as the amount of people who actually solved it, and same with Encryptor, that PPP only solves, right? Yeah, so he solved it in 34 hours. So that's the amount of time it takes to solve a Pawn 500, like 34 hours. So if you're playing a CTF and you are doing a Pawn and you're like, oh, this is like, I'm already 2 hours into this challenge and I actually have no idea how to solve it, don't worry. I mean, totally good Pawn challenges take a lot of time. As you can see, like part 3 here. Well, okay, you should have you needed to solve part 2 first and part 1 as well, but it's still a 7 hour into the CTF when I solved it. So yeah, it takes time. Good challenges take time. Don't worry about it. Try like through, even if it takes you the whole CTF, as it did probably for Mateusz. I think he solved 1 task before that and then focused solely on it. Yeah, even if it's 34 hours, it's still worth it. Especially if you can solve it or you can learn something. Okay, so I'll probably get to the Great Escape Part 3 Pawn in a second. Now, the last thing I wanted to mention is I actually published a blog post. So one of the things I'm currently doing is have this thing. Yeah. And this thing, this is actually an Atari 800XL motherboard, which means like it's an old 8-bit computer. It's actually pretty interesting, and it's the first computer I had, so it's my first computer here. And it was ages ago actually when I got it. I was 6 back then. And I have some problems with video output. It still works. I mean, after all these years, it still works, but there are problems with video output. So I somehow got back into electronics. I'm not really good. I'm not good in integrated circuits and stuff, but I know some basics. And I bought how do you say it in English? An oscilloscope. Yeah. And also some logic analyzers. Thank you to Q3K or KrzaQ again for helping me choose the software. And I did something that I really had a lot of fun doing, which is I found which pins are go outside of the graphical chip to check if I wanted to grab a screenshot, but not from the output, but from the graphical chip. And in the end, I grabbed the documentation, found the right pins, then did some measurements with the oscilloscope first, and then moved to this is a logic analyzer hooked into the correct pins. This is actually not hooked to this pin of this chip. I mean, this chip is not important, actually hooked somewhere here, but there's a track between these two, so it was more convenient to put the this here, the probe here. In the end, yeah, I got some measurements and I was able to write a Python script to convert it into a screenshot, which I was super happy about. I know it's not a hard thing to do, but in the end it was really, really fun. So if you want to read about it, then check my blog post. Okay, so about the changes I mentioned to the live streaming. So as you noticed, probably I did not really live stream during the last month. I think the last live stream was in November, right? That was because December was really busy for me, and then I got back with a cold and I couldn't speak. So yeah, that's the break. But one change I want to do is I found out that I had, I didn't stream every week because I couldn't always allocate 3 hours of the time. I know that the stream was usually 2 hours, but there's also another hour where I need to hook everything up, prepare some stuff. So it takes 3 hours. So I decided to actually cut it down to 1 hour. So today's stream is going to be 1 hour and all the other streams will be 1 hour. And I actually hope to be able to stream every week from now on. And it will be always the same time, which means Wednesday, 8 p.m. Central Europe time. And in the summer, of course, it will be Central Europe summertime, which is GMT +2. Now it's GMT +1. So I hope actually you will be able to get more videos from me, and I hope to be able to pass some knowledge or some bad ideas as well to you guys, to you folks. Yeah. So that's the big change. Apart from that, I actually want to change how everything here looks like. I kind of put it together, and it doesn't really match up too well. So I started looking for a graphical artist to fix some stuff. It should be getting a little better the quality of the streams. So that's the big change in streaming. I hope to do it every week from now on, and only 1 hour, and that should be easier. As for the topics of the streams, I need to prepare still some tool to basically for voting, because I would like you guys to vote about the topics, like what topic would you like me to discuss next? Obviously, I will not be able to chat on some topics. For example, if you ask me about how to solve this crypto 500, I have absolutely no idea. I mean, I can solve cryptos up to 300 points perhaps, but it's not really my category, right? I mean, we have better crypto guys like Redford and Adam I in Dragon Sector, and they usually handle it. So yeah, again, if you would ask me about, I don't know, integrated circuits, I'm a total noob in that, so I couldn't probably answer the questions. Then if there would be some programming questions or some other topics, then that's really possible. I might be able to talk about it. So again, there will be some voting system soon that you guys will be able to vote, basically. Sweet. So let's do something technical. It's like 20 minutes of talking, well, 15 minutes actually. I don't think there are any yeah, I don't think there are any questions. So let's start with, I'll show you the task, the Great Escape Free pwnable with Rust solved only by 10 teams. And again, I'm not really sure why is that, because I considered it not a hard task. And I'm not saying like it was, it was so easy for me, I totally didn't have a problem with it. There were some catch points, and it was just an easy task. It wasn't Pwn 500 that you needed 30 hours to solve. Therefore, I'm really surprised that only 10 teams did it, especially that I found some other tasks harder than it. So, yeah, so, okay. I do believe I have... Basically, the story is like this, that in the Great Escape Part 1, you had a pickup, and that pickup was, you found a key there, and you could decrypt some SSL traffic and get the first flag. Then you could get an address of, an email address of a bot, which you could access through email. You sent him a link, and he would enter the link. And you also found the address of a server where there was a website. You had to find an XSS back there and get some keys from the bot. And also in the pickup you found a file which was, I think, called roach, and it was an ELF file. You had to again decrypt it using the keys you got from the XSS, and that got you to part 3. So that's the story. Now let me maybe try to launch this. Okay, so I actually had to reinstall my virtual machine recently, because I had Ubuntu 14.4 and I broke it in a way I couldn't upgrade the distro to a dist update. And I cannot use Genome, because Genome in the newest Ubuntu server doesn't work out of the box with remote X servers for some reason. I know some of my viewers actually had the same problem, and now I have the same problem. I didn't solve it yet, so actually I have no idea how to solve it. I did try something, and now I'm using console, but I need to still look into it and give it some more time. Okay, there's a question actually about a CCC task. So meta task 1 that was obfuscated C++ stuff. I think I recall the challenge, though I didn't do it, so I cannot say anything out of the box. I think Maryush solved it, or Redford. I need to take a look and ask about it, and maybe for the next stream I will have some information if I still remember it. Though we should have some files somewhere. Anyway, so there should be a roach file here. No, maybe it's called in a different way. No, it's actually my spelling. Yeah. So you got basically, after decryption, you get a 64-bit executable. It's quite short. I have it analyzed under IDA. Yeah, so here's IDA. I actually need to increase the font a little so you guys see something as well. Sorry about that. Now the main function is, let me find the main function here. The main function is kind of short. It's basically like a boilerplate code for running a service, as in create a socket, then bind it to a local port, then listen on it, and then accept incoming connections, then fork. This is important thing you need to remember, that it's fork, because that changes the behavior and the way you exploit stuff. For example, if you get an address and you connect once, you get an address, and everything is randomized, right? But you get an address, and then you disconnect and connect again, the addresses will be the same, because the addresses are established when the process is being executed from the executable execv and so on, but not when you fork into a new process. Then the addresses remain the same as in the parent. So that's actually quite good. It solves ASLR as long as you can leak whatever was the state of the parent. And then it's handle connections, which is the main function. Now I'm going to actually run it. So one fun part was that you could actually find this port using a port scanner, for example, and connect there. I mean this port on the server, on the remote server, right? But it asks you for a password, and if you didn't put the password "robots will be free," then you didn't. You were not able to chat with the service, and you didn't know the password because you didn't have the file, the elf file, until you actually solved part 1 and part 2 of the Great Escape. And when you get this file and you knew the password, then you could exploit the service actually. Yeah, so when you knew the password, then it chatted with you. Let me maybe run it. I cannot run it because this is because I have a different version of this. This is quite important actually as well. As you can see, they are using a different malloc, which means the heap will not be it won't be the standard glibc heap. It will be libge malloc. I think it's the same thing which is used by Firefox. I might be mistaken though. Anyway, I actually had to install Fedora Linux during the CTF to be able to run this challenge and to be able to debug it, which wasn't a problem after I installed it. And it was quite funny because I think on the server there was Ubuntu anyway, and I have absolutely no idea why I couldn't run it on Ubuntu as well. That being said, we can just connect remotely and see what it does. I just need to find my exploit to find the correct address. Okay. I actually hope the CTF was just a couple of days ago, so the task should still be up. Okay, it connected, so let's copy the password. Yeah, and we got here. And then it asks us a couple of questions, right? So I reply something in this question. This is the encryption method. There are 3 methods. Free. You can safely ignore them. 0 is like actually plain text, no encryption at all. What is your current location? That's another question. You answer something. What is your goal? You answer something else. Now it actually, as you can see, echoes the goal, right? This and this is actually echoed. This is quite important because you can use it for leaks. If you can get it to, I don't know, overflow some buffer, then this echo here could actually leak some address. And this is actually what happened. Any last words? You can do something else. And what are you even here for? Go away. That's basically the whole service. You can answer if your name actually begins here when it asks you about who are you. If it begins with bot, as you can see here, yeah, string compare bot, then it would and the last password, what is your goal, I think is set to this. Then it does something else, but that's totally not relevant to the way we solved it, the way I solved it. So where was the bug? That's the first question. The bug was actually in the goal, as in you could ignore this, you could ignore this, you could ignore the current location, but the goal was important and you could overflow it. And it's quite funny because what it does, so again, I cannot run it because I think I would have to run Fedora to be able to run it. Maybe let's do it. I'm going to start the VM just in case I'll need to show you something. Because it's always good to run this kind of task under an L trace to see what's going on. Okay, it's booting up. Now, yeah, so it allocates a buffer, right? And then it's actually a structure. I didn't actually name the fields. I just remembered it's a structure. And sometimes it writes in the middle of a structure, and then it writes at the end of a structure. And when it asks for the goal, right? It asks for the goal here. Here's what's your location, what's your goal. This is basically asking what is your goal, right? It sends it to me, sends the string to me. Then it receives it to a buffer. The buffer is, I believe, on the stack. Yes, it's on the stack. And then it actually receives up to 255 bytes to this buffer. Then it runs this. This is, remember when choosing the encryption method, I said 0 is plain text. It's actually what you choose is an index into an array of 3 functions, 3 encryption functions, where one means don't encrypt, and this is it. This is the function which doesn't encrypt and it just returns the same pointer. So yeah, this is it. Yeah, calling the encryption functions, which just returns the same thing. It just returns this. And then it sends us, I think the same thing, it sends us the same thing back. And then it actually, I think I missed some part. Yeah, I missed this. Sorry, I scrolled down too far. So it receives, then it copies it into the structure. Now the problem is that it starts to copy it at this offset, right? But there is actually this amount of bytes there, and if you remember, the structure was something like 472. Now 260 plus 255 is 500 something, 520-ish, which is a buffer overflow, obviously, on the heap. Yeah, and then it actually copies it here, then sends it back, and then it does a free on some pointer which is on the so it's actually before this it does a malloc. Sorry, where is that malloc? Malloc, where are you hiding? Here. Oh, I'm actually, my cursor was on it. Before your goal, it does an allocation, right? I have absolutely no idea why does it do the allocation. I think it copies the message there for some reason, and then it frees it. And that's the really important part. This free here is super important, and I will get to it why in a second. Yeah, and that's basically it. It again does an allocation here. This allocation here is also important. Again, calls the decryption function. As you can see, the decryption function is like called all over the place. Yeah, and that's the most important thing here. So again, there was the allocation, right? Here, allocation, reading data from us in a buffer overflow, which is happening, and also sending the data to us again. Yeah, this is sending the data to us again. And then there is a free, which I mentioned is super important, and then another malloc, which is also super important. So what do you do? What can you do with it? Let's start with actually, let's start with my exploit. My exploit will not work currently because we did restart the task. And that means that ASLR came in and like scrambled the addresses, which I had hard-coded. So this is my exploit, and what we will need to do, we'll need to do a couple of things. First of all, okay, so here I send the password, right? Then I wait until the next question is asked, which is like, who are you? Then there is a libc address. This address is not correct anymore. And again, I will have to leak it to show you that this works. Then there is my rob chain, which is used afterwards. I just put it here because I know the address of this place, at least I knew before ASLR. And then I choose the encryption method as 0. My location is like, I actually put bash here because I also know the location of this. And I need it here. I need the string to the command to execute somewhere later on. Then what is your goal? What I do is I send 204 bytes, and that's actually the amount of bytes I can send, and I overflow it with, yeah, this is what I overflow it with. This is actually an offset on the heap. So before I do it, I'm going to make a drawing, perhaps. In my paint. Where do I have my paint? I didn't use the application for a long time to show you what's going on the heap, because that's actually really important. Okay, so VirtualBox tells it cannot launch Fedora VM because of reasons. So it's like this. We have I'm going to explain you the situation on heap, okay? First, it allocates the structure, but actually before the structure, it allocates 8 bytes for the pointer, and this is the pointer for the decryption method, right? And it's also on the heap. That's really important. It's also on the heap. So somewhere in memory, somewhere in heap, will be the pointer, which is a function pointer, which is a good thing for us, right? I'm sorry, writing with a mouse is really... I don't write well with the mouse. I'm sorry about that. Then it allocates the structure. Now the structure can be somewhere else because of the way gemalloc works. It usually is close in the memory, like a couple of pages apart, but yeah, but still somewhere there. So yeah, so then somewhere else there is this huge structure allocated, which is again 472. And then you read into it blah blah blah. This is almost not important, but it reads at the beginning something. Then it does the malloc here, and it puts the address that it gets from the malloc here. This is also not really important. And then it reads the goal, and the goal is read here, and then it is read to the buffer on the stack. There is no overflow on the stack. It's just like a buffer on the stack. And it copies it to our structure plus 260. So let's assume it's here. And it copies it here. And there's an overflow, right? Now the question is, what's here? And what it turns out to be here is this buffer, which got allocated, no, sorry, a pointer to this buffer. When you do this malloc, it actually puts a pointer to that buffer here as well. Now the reason the pointer is here, so let me maybe call it P, capital P. The reason it's here because it's part of the metadata of malloc, and I didn't really analyze GE malloc, how it works. What I did is I looked in a debugger, and so this is interesting. That's actually like the pointer, which is also written here. So what gives, right? So we overflow it, right? And then there's a free, which also uses this pointer for freeing for some reason. And which means basically that we control this parameter here. So this parameter here, which free calls it, we control it. So we can free whatever block we would like to free. Now, what block would it make sense for us to free? It would make sense for us to free this pointer. Why does it make sense for us to free this pointer? Because usually in the heap allocators, when you free a structure, the heap manager thinks, it's implemented in an algorithm, of course, but let's say thinks that this size, this buffer might be useful in near future, therefore I will put it in my cache. And it actually will put this pointer to this buffer in a cache, right? Yeah, again, excuse me, my writing is terrible, especially with a mouse. So when we free it, this pointer will be in a cache, and it again, the pointer has 8 bytes, right? Now, what happens next? There's a malloc. Now the malloc here is happening, the size of the malloc is actually related to how much data we send, right, as the user. And we sent, what? We sent 8 bytes. What address does the malloc return then? Well, it checks, hey, do we have like 8-byte buffer in the cache perhaps? Oh, we do, and it's this pointer buffer here. So this malloc will return the same pointer. And what is written there? Well, it actually copies whatever is in the buffer, and in the buffer is what we send there. Our data is in the buffer, so we can override this pointer with our data, with our function pointer, because again, this is a function pointer, right? It's a function pointer, it's really important. Therefore, when this next instruction is executed, the pointer is the reference and whatever function it points to is being called. Therefore, when we put here, for example, I don't know, a system, or actually the start of our rob chain, or actually a pivot which starts our rob chain, then that's it, game over, we have code execution. And now, this looks really easy, and it actually was easy. I didn't had to analyze GE malloc. I just checked what's pointer here, what happens when I do free, and I freed this because it makes sense to free it. Now, the only part which did take some time to figure out was what's actually the distance between these two buffers, right? What's the distance? Because on my machine the distance was something else, on the server the distance was also something else. So what I ended up doing is, I think you can see it commented out here, is I ended up brute forcing it by 256 bytes. And as in, I did try every address and going by incrementing by 256 bytes, because I actually knew that it will be because it's a small buffer, it will be at the beginning of a different region. So these regions will be separate. This will be like region 1 and region 2. That's actually all I read about gmalloc, that it has some kind of regions for bigger and smaller buffers. And I knew this will be before, so I brute forced basically on the server until I found this address, and it was quite close. I think I had to try this, I don't know, like 1,000 times, maybe 1,000 attempts is not that much, so I was pretty lucky to get the offset. And I got the offset, and then it was just, basically history, right? You just, well, first of all, I started leaking things all around, and I leaked what are the addresses of some functions, right? Of libc functions. When I asked around for my team, like, so okay, I have the address of this of libc start main. This is the address, and fputs has this address. What C library is it? And they found me the right library. There are actually databases on the internet. You probably know, like libc database. Yeah, for example, this one, where you can, again, put two symbols, right? Like libc main and something. Then you click search, and it tells you what version of libc is it by looking at the end of the addresses. It's something that usually a CTF team had. We have our own, I believe, and but there are also public ones as well. And having this, I get the libc, right? And having the libc, I can basically write a ROP chain. My ROP chain was rather small. I did put some address here. This was the address of this buffer. I knew the address because I leaked it at some point. And yeah, and I called system, right? That's it. And what I did is I run bash in bash, and system actually run binsh, and I redirected it into dev tcp, my IP address of Ginveil called win.pl, and some random port, and I was waiting there with a netcat on listen mode, and when it connected, I actually got the shell, I don't know, first try. So, or second try, actually, I had some mistakes in the first try. I know this didn't work in the first try, but I needed to add bash-c. So, yeah, that was basically it. Now, how did you leak? That's a good question. You leak easy when you overflow the buffer, right? When you overflow this buffer, then just overwrite 1 byte. This 1 byte here was usually 0, and you overwrite it, and therefore you changed this. When it echoes back the output, right? What it does string length on the message. And, well, since you just removed the 0 byte here, it would go, string length would go here, and actually include the pointer. So you get the pointer, and you'd be quite happy with it. Then I did some other leaks with replacing this pointer by something in the binary, which actually sent me some data using the send command. I was quite lucky because I think it's even in my ROP chain here. Yeah, as you can see, there is calling a send, and the send is actually the send function, because I could control the source of what will be leaking for some reason, and the length was, I didn't control the registers for length. I was controlling for some reason because there was actually a gadget in the binary itself. There were not too many gadgets in the binary itself, but there was set RDE, which is this one, right? So pop RDE, red, no magic here, and this is an address which is in this binary. So you control basically what you read, and then you call into this function. Where is this function again? Let's go there. Yeah, you call into this function, and it sends you data to your socket. Because actually all the other registers are set to correct values, so you don't have to set them. So that was the leak vector. And that's it. So the only hard thing here, the only thing which was somewhat hard in this task, even if you never exploited heap, I actually am not really good at heap. I am bad with exploiting stuff on heap, but I was able to, like, this doesn't require knowledge of a heap manager. How does the heap manager really works? You just need to know some basics. Yeah, so the only thing was that this offset here, the distance between the regions, actually differed on my local VM and it differed on the server. Therefore, you had to brute force it. That was the only problematic thing here. But when you think about it, it wasn't really that problematic, right? You just like brute force it, and if it worked, then you got something, right? And yes, and again, only 10 teams solved it, so I'm quite surprised because again, it wasn't a hard challenge. But yeah, so that was the challenge. I'm actually not going to correct the exploit today. It would probably take some more time to do it, or maybe we have still 10 minutes, so maybe I can correct it and show you guys that it actually worked. So the word guys is quite funny because it's supposed to not include all the genders, which I get different opinions from native speakers on, actually, so I might be switching to folks since that's more inclusive, which is good in the end. Anyway, okay, so let's fix this exploit because I don't have any topics for the rest of the last 10 minutes anyway. What's the current state of the exploit? That's a good question, as always. The current state of the exploit will be, let's disconnect it. Failing. So it does leak a pointer. As you can see, it does leak a pointer here. This is the pointer to the heap. The one which is after the buffer is this pointer, right? And it does get it, which is fine. What it displays is actually it displays the version which is already overwritten with, as you can see at the end here is 9008, and it's 9008 here, and I replace it with some addresses. Now the address is, this address is not correct. Also, our system is not correct because this address is in libc, and I do not know the address of libc, so what I need to do is I need to get the address of libc. Now send is the address inside the main binary. The main binary is not ASLR. If I do check sec -- file on roach, there's no pi. Yeah, which means there's no position independent executable, therefore it's not relocatable in a classical ASLR sense. So I do send and I do set RDE, and I set RDE to 4. No, I don't set it to 4. Let me do one thing. One thing I always forget is like what's the order of parameters. Oh, it's no, okay. Yeah, I was like looking ECI. What? I thought it was a 64-bit binary. Why do I see these registers here? That's okay. This offset, that's quite funny. It's an ECI and not an EDI, which I'm not too happy about. But this is again another opcode which allows me to set the RCI register, which is good. So I'm going to set RDA to 4. Why 4? Because I'm pretty sure that the descriptor of the socket is 4. Why? Because, well, you know, you have 0 is standard input, 1 is standard output, 2 is standard output error. 3 is if you go back to main, is this main? Yes, this is the main. Then you create a socket. Now a socket actually creates a file descriptor as well, so that's number 3. And therefore number 4, it will be whatever accept returns. That will be always number 4, because there is like no other descriptor creation here, and the descriptors are not random. Therefore I know that my descriptor will be 4. And I can use it. So I can set RDI to 4, which will be the send descriptor. Now I need to set RCI to some address. The address which I'm going to set it to, it's actually already here, which is this address, which is got.plt. Let's do it like this so I can show you, which is the global offset table or the procedure linkage table, right? And it has all the offsets to, when I leak it, I will get pointers of this stuff. and it will be again sent to me. So I need to expect it, though. Before I expect it, I'm going to actually show you that it works. And I don't know, I don't think it works. But it doesn't work due to a different reason, probably. It probably doesn't work because I need to brute force the offset again, which is annoying, but we can run it. Okay. Yeah, I'm pretty sure that it's because of this. If I actually don't do this and don't do this and do just this, then it should not crash so... Then it shouldn't crash so fast. Yeah, it goes to the last... so yeah, that's exactly the problem. This address is actually, well, this is the CC, right? The CC which I overwritten it is 43 in, if you check in the ASCII table, and the rest is actually a valid heap offset num, valid heap address, so I'm going to save it somewhere here. I usually have another document for, how do I copy from this console? Copy Ctrl-Shift-C. I'm going to just write it. And as I told you, there was like 00 here. So I'm going to brute force the address. This is FF here. I'm going to start from 00. And what I need is I need a parameter in my function. And I need to do this. And I need to overflow it with... Why was it? 7. Oh, I know why was it 7.3, because I actually, like, before that, here now I have BF, right? But before that I had 7.4 and I needed to scan backwards as well. So I added this. And the offset is set to nothing. The offset should be set to I. And if something works, I should get quite a lot of message due to my rob chain actually working. I should get the send to work, and that would differ it from all the other runs. So I'm going to receive it. Oh no, I'm going to actually receive something else, because I need to be able to somehow detect it. So how do you do it? You find a random string, for example, robots will be freeze at this address, and you actually read this. Yeah. So I'm going to send to myself robots will be free in case my offset is actually correct. Therefore, okay, blah blah blah. Receive print k. If robots in k, then actually sys exit, because that's it, right? 0. I can print I as well, just to be sure. And I need to uncomment this. I start off. So I know that it will be the offset of the pointer will be always 8 from the beginning of the region. So the offset of this pointer is always 8 from the beginning of the region. Therefore, I'm starting at 8 and incrementing by 256. I think even if I increment by 1000, that should work. So let's do it. It will be faster. Now let's see if this brute force takes one argument, and I didn't give it any. Okay, I understand. Blah blah blah, and the brute force is running. It might not work, it might work, we'll see. Doesn't seem to have worked, so I can change it now to actually 100. Okay, so the question is that Blue Yeti? Yes, that's a Blue Yeti. It's Blue Yeti Pro, if I remember correctly. Obviously, it might not work because, you know, it's a demo, and demo never work, especially when you're doing a presentation and you want something to work. You better have a video ready, because there's a pretty good chance it will not. So it's pretty possible that it will not find the correct offset. So the next thing, if this fails, the next thing I'm going to do is I'm going to increase it again to 1000, but I'm going to add the same as was here. Sorry, where was it? Yeah, I'm going to basically add the previous address. So this address is BF. I'm going to do BE. B. Yeah. To check also the previous, like, how many 16 pages? Nothing works live. That's true. What's the current address? It might be going too fast for you, so let's do it like this. This is the current address it's scanning, so it's almost finished. You know, there's also a chance that I actually screwed something up and I do some other things later, which I added later in the exploit, and that's why my scanner is not working, but it actually did find something, so I can run it immediately because I did already modify everything. No, I did find it. So this is the correct offset of the pointer, BE7008. So F is 708, and the BE is already here. So I'm not going to remove it. Now I can remove this. I can start with, I don't know, 1. It doesn't matter anyway because I'm not using I anymore, even though I'm a little sloppy here. And now I'm going to uncomment. No, now I need to, since my leak already works and I leaked the, you know, the string, right? Now I need to again leak the got.plt to get the address of libc because there are gadgets and there is system comment in that. Therefore, I'm going to comment this and uncomment this, and I'm going to run it. So it works, but I actually need it in a little more readable way, perhaps. And I don't. I need to comment this out. Now, is there a way? Oh, no, perfect. I actually do have already like let's start with a memset there. All the names copied and ready to parse the data which I got. Cool. So my memset is at some location. Now I need to figure out which function was this. And it's not here, which isn't perfect because I need to run the glibc inside this and check where is memset. Memset is at this address. Sorry, what is the function on this address? The function of this address is listen, but I didn't dump listen, I dumped memset. As in, not enough data was sent to me, therefore I have the address of memset, but I do not have the address of listen, which doesn't matter at all. It can be like whatever. No, I cannot copy it again. Come on. Okay, and I need to copy this address and subtract it, and this will give me the base of libc address, which then I add this value to. So if I go here, this actually system, as you can see in the C library, right? And now I need to do something. What am I going to do? I'm not going to run it. No, I am going to run it. I need to run it. So let me connect to my shell. Okay, so here we are. Let's see. -L -P 1 2 3 4. So basically, I tell it to listen on this port, and I'm going to run this. And no, sorry, I'm going to comment first some stuff out, and then I'm going to run it, obviously. So I'm going to comment this out. Now I'm going to comment this out as well. Actually, even maybe receiving this, I don't know, I can leave it, I don't care. I just need to comment this out. And I'm going to enable the interactive Python sesh like this, just for my socket to actually hang. And it didn't work, because why would it? Let's see what I screwed up. Okay, this address is incorrect, which is the address of the heap on the heap of my buffer where I have the comment, and I need to change it. Here was this is what I put here last time, so let's comment this out and do something like this. This might be the same address. If not, I'm going to brute force it, because why not? It's probably not it though. Let me do it something else. I'm not going to call system yet, I'm going to call send, therefore I'm going to put this address into RSI. And I already did it. Perfect. So I'm going to leak it. Like leak what's on this address, right? But that's my leak here. Though I didn't set this. Okay, now it's correct. Okay, so this is actually there. So I don't understand, it should work. Oh, okay, let's try it again. So system, and I put in RDI, I put this. This is listening, let's try it. No. What did I miss? What did I mix up? The send is not important here anymore, this should work. But that does work, right? I mean, just I cannot call system. This doesn't work, and this should work. No. Yeah, this should work. Okay. There's maybe someone connected into my NC. No, nobody connected. It would, I'm -v here, so I would see if somebody would connect. There's so the thing which you do here to test it, because you know debugging a random remote exploit is normal. I mean, I'm not surprised that this doesn't work. What you normally do is you change the shell command to sleep 10. If it works, it will sleep. It doesn't work, which is bad. It's actually quite surprising why it doesn't work, because it should work. Did I get the offset wrong, for example? Let's do something like this. Let's do something funny. I'm going to actually grab this, which is the address of system, right? And I'm going to leak it. I'm going to see what bytes are there, and so I can compare, you know, to my IDA. If it's maybe I did something wrong there. Oh, wait. There's something really wrong here, though. What is happening here? So I'm saying that something is happening here because the last 3 bytes on the page are always the same, and this is not the same. Which means I screwed up this part, which is good, because now I know what's going on, so I can fix it. Again, I'm going to leak got.plt, not this one, this one. Going to send it to myself. And I'm going to uncomment this again. Yeah, and let's just go for it. Do I have a different version of libc opened? Why do I have a different version of libc opened? Is this libc? Oh, this is the dumped libc, because I also dumped it from before I had it. Which is really weird. Let's see close, maybe not flows. Close, obviously. Does this have the correct? Close. Yeah, let's use close. Close has the correct offset. I don't know what happened there. Maybe I don't have, like, you know, the exact correct libc, but it's close enough for system to actually work. And guess who has to transcribe another address by hand? Yeah, I really need to get Genome Terminal working again. 3D00, and maybe I forgot 10 when I was transcribing the last one. Yeah, in any case it should work. At least I hope it will work. You know, it's never easy. Sweet. Here's my shell run. And it's not connected. Why didn't I? Because it's sleeping. Because I didn't command this. Yeah, let me move it here and move this here. Now let me uncomment my reverse shell. Run it. Run this. Blah blah blah. Okay, I'm here. Actually, you cannot see what I'm doing, so yeah, cut flag. Yeah, and that's it. So yeah, again, apart from leaking, because I didn't automate leaking, though I should automate leaking probably during the CTF, and I just hard-coded the addresses, I needed to fix that before my exploit worked again. And it worked in the end after some debugging. And again, sleep is useful, dumping memory is useful. You know, when debugging remote stuff, it's when debugging anything, it's basically all about data. It's like, you know, if you saw Sherlock Holmes movies and he's like, data, 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 I need, without bricks, I cannot build walls and so on. That's basically it. You need a lot of data, and when you see the data, it tells you something. If you don't have data, get data. And in my case, you know, I dumped PLT, I dumped the heap, and I ran sleep, and this allowed me to debug it in 15 minutes and 8 additional minutes of a stream. So that's it actually for today. I'll take a quick look if there is any question on the chat. There will be next stream, again, 1 hour next week. Also, actually try to do some videos apart from streaming, you know, better quality with editing, short videos, about 10 minutes on random subjects. But I hope you will like it. If you already solved it at the CTF, why do you still need to write an exploit? So I wasn't writing the exploit, I was making the exploit work because the address is changed to ASLR. Actually, the challenge was restarted on the server, therefore the address is changed but they don't change with each run due to fork being there. Okay, I think that's it. So thank you very much for joining me, and actually see you next week. And if you liked it, leave a hand up on YouTube and tell your friends about it. You know, the more the merrier. The more people come, the more inclined I will be to actually make the streams and make them regularly. So thank you very much for coming today, and have fun and see you. Bye bye. Now, how do I switch it?